To sketch a linear graph, you only need 2 points. The easiest way of doing that is to find the two intercepts. If I want to find the x-intercept, I just need to let y equal 0 and solve for x. And that's because anywhere along this line, I haven't gone up or down, so anywhere along here, y is 0. The same can be said for the y-axis. Anywhere along here, I haven't moved sideways in the x direction, so anywhere along here, x is 0. So y equals 0 gives me the x-intercept, x equals 0 gives me the y-intercept. So let's work those out. So I'm going to let x equal 0, so 3 times 0 plus 2y equals 6. 3 times 0 is nothing, so 2y equals 6. Divide both sides by 2, so I can cancel the 2's, and y equals 3. So the y-intercept is 3. Now let's make y equals 0. 3x plus 2 times 0 equals 6. So 3x equals 6 because 2 times 0 is 0. Divide both sides by 3. These cancel. X equals 2. So 2 is where the x-intercept is. Now I just need to sketch a line. And there is the graph. Again, for this question, I'm going to let x equal 0 and solve for y. So if I let x equal 0, I get y equals 2/3 times 0 plus 2, which just is equal to 2. And we already know that this number on the end is the y-intercept, so that makes perfect sense. So that point is here. Now let's make y equal 0 and solve for x. To solve for x, I need to get rid of the 2, so I subtract 2 from both sides. And that means I get minus 2 equals 2/3 x. To get rid of the 2 and the 3, I can just multiply both sides by 3 over 2. This 3 and this 3 cancel, this 2 and this 2 cancel, and this 2 and this 2 cancel. So that leaves me with minus 3 on this side, because minus 1 times 3 is minus 3, and that equals x. So minus 3 for x is over here, and I just need to sketch it. And there is the graph. Again, using the intercept method for this one here, if I let x equals 0, I get y equals 3 times 0, which is actually 0. That tells me that it goes through this point in the middle, which is called the origin, and that was pretty obvious anyway, because over here there is no c value added on, so the y-intercept is actually 0. And if I don't go up any distance in the y direction, I stay at the origin. So there is the intercept for both axes. It's a little bit of a problem because it means I don't have, if I try and solve for the y-intercept, I'll get the same point. So I just need to pick another value. So I'm going to let x equal 1. So therefore y will be equal to 3 times 1, which is 3. So I've got a second point, which is 1 and 3. It's not an intercept, but the problem is I couldn't use two intercepts because they're both the same value or the same position. So let's draw the graph. And there it is. A second method for finding or sketching the graph is to actually use the intercept and the gradient. The intercept's easy when it's written in this form of the general equation with the minus 1 at the end being the intercept. So I can straight away plot that as one of the points. The gradient means how steep the graph is. If I have a run of 1, then the rise will actually be 3, because 3 over 1 has to make 3. So that means if I go across 1 and up go across 1 and up 3, 1, 2, 3, that will actually give me a second point. So I'm using the -1 as my starting point on the y-intercept, go across 1 and up 3, and I get a second point. So let's just sketch that graph. And there it is. This next question is a little bit more difficult to do using the gradient intercept method because the equation is not written in the general form of a linear equation where y equals mx plus c. So we need to rearrange it. So what I need to do is get rid of the 3x and the 2. In other words, make y the subject. So I'm going to subtract 3x from both sides first. Over here, this one and this one subtracted make 0. So I end up with -2y equals 6 minus 3x. To get y on its own and make it the subject, I need to divide by -2 on both sides. On this side they cancel, so I just end up with y. On the right hand side, the -2 is being divided into both parts of the expression. So I'm going to end up with -3 plus 3 over 2 x. So that means that the y-intercept is -3 because it's here, and the gradient is 3 over 2. These two are back to front than what we've normally seen, but because the 3 over 2 is next to the x, it's the coefficient of the x, it's the gradient. So let's plot the -3 first, so that's down here. And to get another point, I can use the gradient. Now because it's 3 over 2, the rise over the run is 3 over 2. So I'm going to use that to find the next point. I'll go across 2, I'll run across 2, and I'll rise 3. That gives me another point. Now I just need to sketch it. And there it is. This question would be so much easier to do using the previous method, and I would never actually do it this way, but just to show you that it works, I used this method. If I was using the previous method by letting y equal 0, I'd get 3x equals 6, or x would equal 2, and there's that point there. If I let x equal 0, I'd get -2y equals 6, and y would end up being -3, which is that point there, which is way easier to work out. There are two special types of linear graphs. This one here, y equals 4, means that it doesn't matter what x is, y is always equal to 4. So for that graph there, I just need to draw a line where y is always equal to 4. And that's a horizontal line like this. So for this graph here, the y value is always 4, no matter what the x value is. Y equals 4 is a horizontal line. X equals -2 is a vertical line, and the vertical line is at the point x minus 2, because x is always -2, doesn't matter what y is. So I draw a vertical line, and the line needs to be -2 along the x-axis. So you can see that anywhere along here, I've moved -2 from 0 in the x direction. For the horizontal line, for y equals 4, I've moved 4 up for every point on the line. So this line here is a vertical line at x equals -2. This is a horizontal line at y equals 4.